Hello class, this week we're working on polynomials, and the first problem that we're going to work on today is an exponent and integers. As you can see, we have two problems that we have to work on. Once again, please make sure to use your calculator. Learning the mathematical rules can get a little confusing, so just make sure you have your calculator handy. As you can see here, the only thing they did for the first problem, they have a -2 in parentheses with an exponent of 4. So what they did was they multiplied -2 in parentheses 4 times and ended up with a positive 16. Make sure to include the negative sign because you'll end up with the incorrect answer. With the second problem, it's 5 with an exponent of 3. 5 in parentheses, and they multiplied 5 times 5 times 5, and they came up with a number of 125, and that's also a positive number. As you can see that the base, which is 5, that's positive, and the exponent is positive, and there was a positive outcome here. Okay, let's move on to the next problem. Okay, this problem is very similar to the previous problem, except we're working with fractions. So once again, please use your calculator. As you can see here for the first problem, it is a negative sign. It's when you see a negative sign, it's not a number, you automatically know that it's a 1 in front of it. But sometimes the one, you can put the 1 there, or you can decide to not put the 1 there. So they didn't put the 1 there, but anyway, there's a negative sign there, and then in parentheses is 1/2 with an exponent of 4. So when they worked the problem out, they simply put a -1 here on the outside, and then they multiplied 1/2 4 times in parentheses, and they got a -1/16. Okay, as you can see, once you multiply, if you multiply 1/2 4 times, because the number inside of the parentheses is positive, however, you have this -1, and once you multiply the -1, then that's why the problem is negative, because you multiplied the -1. Here at the bottom, you see the only thing they did was they have a -2/5 in parentheses with an exponent of 2. So the only thing they did here was multiply. 5 times 5 is 25, and then 2 times 2 is 4. And you can always use your calculator, but just a rule of thumb, 2 negatives equals a positive, and that's why the result is positive here. Okay, for this problem, we have to use the order of operations. I know I stated in class last week that the order of operations is please excuse my dear Aunt Sally. So make sure that you use the parentheses first, the exponents next, multiplication, division, addition, and subtraction. So that is the order of operation, and that is what you must use here in order to get the problem correct, to get the answer. So here you see we have a fraction inside of the parentheses. We have an exponent, and then we have an addition, and then we have a subtraction here on the side. So here how we work this problem. The first thing we would do is work what's inside of the parentheses. So you have a -4/2, and so that will be a -2. So you can see that here, a -2, and then they brought down the exponent of 2 and then carried over the negative sign. So what they did here was just simply multiply -2 times -2, which gives you a +4. But then once they multiplied the +4 times this negative, then you have a -4, and then you end up with +3 -1, and they just brought these numbers down. Of course, a 1 with an exponent of 2 is 1, because 1 times 1 is 1. So they simply just brought that down, and then you can just simply put in your calculator -4 + 3 + 1, and then you will get a sum of -2. Okay, let's move on to the next problem. Okay, this problem requires us to understand the product rule of exponents. So here we have y times y with the exponent of 5, and we have to fill in the blanks. So they want us to remove the exponent of 5 and then just write it out in its expanded form. So we would actually keep the y, and then we would say times y times y times y times y times y. So we would write that out 5 times. And you can see that they've done that there. And then they still carried down the y. And so once you add all of the y's together, you have 6y. So that's the response to that one. Let's move right along. Okay, this problem focuses on the product rule with positive exponents in a univariate type of problem. So here we're going to multiply -4w squared. Then we have in parentheses a -7w close parentheses. So here we're just going to simply multiply -4 times -7, and you should get a positive 28, because remember, a negative times a negative equals a positive. And then with the two w's, only thing you do is add them. So you have a w with an exponent of 2 and a w with the understanding that that's a 1. So you just simply add them together and you get a 3. So the answer is 28w with an exponent of 3. Let's move to the next problem. Okay, this problem requires us to group like terms together. So we're working with the product rule of positive exponents. The only thing we do is group like factors together. So for instance, we have the numbers 8, 3, and 2. So we take all of those numbers and simply multiply them. So you will multiply 8 times 3 times 2, and you will get a sum of 48. And then you have the you have a u here, a variable u, and then you have an x. So you want to pull out everything that has a u with an exponent. So we have a exponent of 3u and then an exponent of 7, and then you would add the 3 and the 7 together. And then for x, you have a 8 and a 1, and you would add those together, and then you come up with the sum 48u with the exponent of 10, x with an exponent of 9. Okay, this problem requires us to understand the power rules of exponents. So here we're going to work on a problem that has 3a close parentheses with an exponent of 2. So here we're just going to simply multiply 3 times 3, which is going to give you a sum of 9, and then a times a, or with an exponent of 1 on the outside, will give you 2. So you have a with an exponent of 2. Let's move to the next problem. Before we move on to the next problem, you see that they did ask us to write the problem without using the exponent, and you can see here we have 3 times 3 times a. So if you want to write it without the exponent, you would just simply write the expanding form of a squared and just write a times a. Okay, this problem wants us to write the answer without using the parentheses. So here the problem is close parentheses u with an exponent 3, close parentheses with an exponent of 3. So here the only thing, they go through a lot of steps here, and you can definitely use all of those steps, but you could simply just say 3 times 3 equals 9 and just put u with an exponent of 9, and you can see your response here. They also show you this way here at the bottom. They just put that, they just wrote u 3 times 3 equals u with an exponent of 9. This problem requires us to just simplify the problem that we have in front of us. So here we have close parentheses 7a cubed b close parentheses squared. So here the only thing we're going to do is we're going to multiply the exponent of 2 with everything that's inside of the parentheses. So we have 2 times 7, which you would actually multiply 7 times 7, and that will give you 49. And then here you have a 3 and a 2. And so you would multiply 3 times 2 there and get 6. And then for B, there's not an exponent there, but it's an understood 1. So you would say 2 times 1. And that will give you an exponent of 2. So the response is 49A with an exponent of 6, B with an exponent of 2. Okay, power and product rules with positive exponents. This problem is very similar to the previous problem. As you can see here, we have an exponent of 2 on the outside of the parentheses. So that means everything within inside of that parentheses will be multiplied by 2. Okay, so here we have 2, the exponent of 2, and we have a number of 2. So you would multiply 2 times 2, and you would get 4 like you have here. And then you would multiply 2 times 3, which would give you 6. And then we have 2 times 1 because there's not a number on the side of the 1. So, you know, that means 1 if you don't see a number. So it would be 2 times 1 equals y squared. And then you see that there's a 3 and a 2. So you multiply 3 times 2. And you will get z with an exponent of 6. So what you would do here is just simply add like terms. So you would bring down the number 4 or negative 4 because you see here you have a negative x here. So you would bring down the negative 4 and then you will add the 4 and the 6 together on the x, which will give you 10. And then you will add the y's together. So you have a 2 on both sides, which will give you a 4, and then you have to add the z's, and you have a 2 and a 6, and that gives you an 8. So here is your answer here. Okay, let's move to the next problem. We have to look for a common denominator, and this type of problem is called simplifying a ratio of multivariate monomials. Okay, so here you see we have a division problem. However, when you see a division problem that's written like this and it has the alphabets on the end, is what students like to say, we have to divide. So we divide and subtract. So here we find a common factor. So we have 10 over 35. And so a common factor of 10 and 35 would be 5, right? So 5 will go into 10 2 times. That's why you have the number 2 here. 5 will go into 35 7 times. That's why you have the 7 here. And then you can see here, now you will begin to cancel out your A, B's, and C's. So there's not an A, so you would bring down the A, right? But then you have a B up top and a B at the bottom. You would cancel those out. And then you have a C at the top and a C at the bottom, and those would cancel out. So that leaves you with 2 over 7A. Let's move to the next problem. Okay, this problem is very similar to the previous problem we just worked on. It's a division problem. However, we are going to find a common denominator that will go into 7 and 28, and then we will subtract the variables. Okay, so we have 7 over 28. What number will go into 7 and 28? And that number is 7. So you will have 7 to go into 7 one time, so you'll put a 1 there. And then 7 will go into 28 4 times. So you'll put a 4 at the bottom. And then 3 minus 7 or 7 minus 3 will give you an exponent of 4. So your answer is 1 over 4 u with an exponent of 4. Problem is also very similar to the last two problems that we've worked on. Here we have a division problem. Since we do not have a whole number in front of any of the alphabets or variables, we just simply subtract what we have. So 7 minus an exponent of 1 will give you 6. 4 minus an exponent of 3 will give you 1. So you have x with an exponent of 6, z with the z. All right, let's move. Okay, for these type of problems, when you have an exponent of 0, students freak out. So anyway, when you have an exponent of 0, it is an automatic 1. So you automatically know that if you have a exponent of 0 on the outside of the parentheses, that the response for that, or the sum for that, is 1. As you can see, you have in parentheses a -5, close parentheses with an exponent of 0, so the response for that is 1. And then you have, in the next problem, you have a whole number of 2, but in parentheses you have 2/9, close parentheses with an exponent of 0. So you also know that the sum of what's inside the parentheses is 1. So then you will multiply 2 times 1, which will give you a response of 2. And you can see the answers here. Okay, we have one last problem. An expression with a negative exponent. Here they want us to evaluate this problem and take away the exponent. It's a very simple problem. Just keep this in mind. If you have a number like we have here, 8, with an exponent of 2, and you want to get rid of the exponent, we can just simply make this a fraction and just put negative 1/8 with an exponent of 2, and that simply makes that a fraction. And then here you will see you will multiply 8 times 8, which will give you 64, and the 1 stays, will definitely stay the same. So the answer is 1/64.